Okay, hi, I'm Bruce Gray, util online. This talk is command line filters. A few code examples will be in Perl, in Raku, in Python, but this material is applicable to many languages. Those are the three that have the best support for creating filters. But a lot of it's not even about that. It's the basics. So it will apply no matter what you program in, or even if you just do data munging and never ever work in one of the fundamental languages. Really? I'll step closer too. Better? Somebody tell me it's better. Wave if you cannot hear me. The first third of this talk is very basic, as in someone in my preview talk just left. Too basic. On the other hand, some of my workflow you will see later, might seem past intermediate, partly because it's unfamiliar to you, but even my advanced preview audience learned at least one new trick. I will cover the concept of filters, how to use filters with redirection and piping, real workflows using those tools, including a few of my best tricks that I use every day, how it all works under the covers, and how and why and whether and when to write programs in that quite easy filter format in 45 minutes. Sound good? I planned this talk after I had to teach bits of it to 3 different programmers in 3 months. Skilled people working in tools that kept them far away from the command line. We don't have time to cover the very basics of like getting to a command line and changing directories and what the differences are between the command line syntax on Windows versus Unix. Google is your friend. So if you need something even more basic, there are actually a lot of YouTube videos at that level. And this is command line filters. Command line Perl is a class that Walt Mankowski, Waltman and I used to like take turns giving every year. It's great for data munging. That is a real one-liner from my command history. That's what you learn in command line Perl. That is a totally different talk. Today's command line filters, much more basic. Can everybody see the slide at that resolution? Great. If you can't, there are seats. Pardon? Oh, yeah. Like whether you can grasp it is a different story. Okay, the operators of redirecting are right angle, or the greater than symbol, double right angle, left angle, and the pipe operator is the vertical bar. Let's dig in. SEQ is just a little utility that lists a sequence from the low that you specify to the high. It doesn't read from any files. It just writes to standard output, which is your terminal screen. It's simple, so I'm going to use it as a starting point for a lot of my examples. Right angle is a redirect. It makes the output that was going to go to the screen go to a file instead. It creates the file with the name you give it, or it clobbers the existing file that was already named that. So if you already had an A.A, now you've got a different A.A, and the old one's gone. I use file names like A.A, B.B, C.C, because they take little finger movement to type, and I don't touch type. Your mileage may vary. On Windows specifically, you might want to use like A.txt and B.txt because Windows cares more about file extensions than Unix. I don't have a slide, but and I haven't actually tried it, but I got the tip that it's even faster to name it like comma A, comma B, because that way you can just delete all the comma whatever temporary files when you're done. grep selects lines from its input. You give grep a rule, and it uses that rule to decide for every line whether to print it or to skip it. Here, my rule is that the line must contain the digit 1. The rest of the command line is a list of all the files that grep is going to look into to get its lines. So if we run this, we will get 10, 11, 12. SEQ is not a filter. It doesn't read anything. It only writes. grep is a filter. It reads line by line and writes something based on those lines. If you were dealing with just one file, you can redirect in the other direction for grep. You're going into the grep command, because the standard for anything that's written as a filter is in the place where it's looking for what files am I operating on. If you don't tell it any files, it looks to standard input. This is the reason why occasionally you think things are just hanging on the command line, because you've done something that is expecting input from standard input and you haven't redirected, so it's hooked to your keyboard. It's waiting for you to type in the lines that it's going to operate on, which is an unfortunate design element. It works perfectly if you do the right thing. So, left angle redirects a file into the standard input, just like right angle redirected standard output to a file. They're complementary. This version doesn't seem very useful. I had to type an extra character, but it'll become clear soon. The cat utility, by the way, you may not have cat or sequence or grep on your particular system, but these are just examples. You will have things that run on your command line that come to standard output, that take standard input, even on Windows with nothing Unixy installed. So cat, it just reads whatever file you tell it about and sends every single line to output. And the vertical bar, this is the magic, it connects the output of one command to be the input of the other command. There was something recently that I didn't get into the slides where they talked about, they talked to the guy that put the pipe system call into Unix and the design discussions that went around it. But it's very powerful. Now, unless you have multiple files that you're concatenating together, the left arrow form is technically more correct than doing this with cat. Back in the Usenet days, like before the web, Randall Schwartz used to give out useless use of cat awards. If you don't need the output in a file, if you're not going to do something yet again, no. If you're not going to do something completely different with A.A, you don't need A.A at all. With the pipe, you can just go directly from sequence into grep. These should all produce the same output. Using the vertical bar like that, the pipe symbol is called piping. And programs that are designed to expect their input in this way, files on the command line or standard input, and they're designed to produce output in this way, standard output, those two things together make it a filter. Pagers are popular filters from back in the days when we had no scroll back on our terminals. More was the first pager I used until the improved version came out, which geeks, right? They named it less. I actually don't use more or less, the more utility or the less utility, much on my local systems. Because my editor, my text editor, probably your editor too, can take a pipe to an unnamed buffer. So the command for my TextMate editor on Mac is mate, M-A-T-E. If I pipe to that, it pops up in my editor. I abbreviated that to M. I really should have used E, so I could be using the same letter on every system that I work on. But now M is in my fingers. If you're going to do this, maybe E for just edit. So that's the output sequence of 1 to 999 popped up in my editor. I have full control. I can search, I can move around, I can move stuff around, I can copy from here and paste into a named buffer, and all with familiar editor keystrokes, because programmers live in their editors. So that's the tool that you should have absolute mastery over. And I have to pause that train of talk for a moment. Atlanta Perlmongers let me preview this talk. Thank you, guys. And they gave me a piece of strong feedback. Don't say M. You use that on several slides. Spell out mate. Don't burden your audience with remembering your customizations. That's a good point. But this is an important technique. If you are just not always working with output so big it would kill your editor, then find out how to make your editor do this and make a one-character alias for it. Give yourself your best tool to survey your output that you're studying to see, is it right, is it wrong? This is trust me on the sunscreen advice, okay? Okay, back to redirecting output. The last basic redirect is 2 arrows, which means to append. So the first line, whatever's in A.A, disappears and it just gets 6 through 12. Run the second line and it adds 6 through 12 again. So now we've got 2 sets of lines, 6 through 12 and 6 through 12. Real-world examples. CSV Kit is a package of command line tools to manipulate CSV files. Every one of those is written as a filter in Python. But many months, these things are the only Python I use. The quality of the CSV handling is just shy of Perl's CSV _ text : CSV _ XS. That's a really high bar. About the only thing that they're lacking is the deep error handling that Perl's version can give you if you're trying to work with bad CSV and handle the badness in programmatic ways. If you don't need that level of depth, then this is awfully convenient, really well packaged. So as part of some process, I was extracting the 5th and the 13th column from some CSV file. And I wanted to change from selecting by column position to selecting by name, because there's a line at the top of the file that names the column header, because that file turned out to be subject to randomly people rearranging columns without telling us. So that change, that's a kind of refactoring, right? Minimal, but it's a change that shouldn't alter the output. But I needed to verify quickly that it didn't change the output, because I wasn't sure that I was doing this right. What if I counted to 13 wrong across the columns to get to postcode? Or what if I started at 0 instead of 1, or 1 instead of 0? So, get a checksum. That's MD5 on my system. I have a MD5 sum on your system. If the checksum matches, then so does the output. This technique is better when you are purely refactoring. You're doing nothing but refactoring. So you're confident that no change was made. Like the weekly challenge and Rosetta code, I spend at least twice as much time rewriting my solution as I did solving it in the first place. You got to make it look good. People are going to be watching, right? Slightly different technique. You run your program, put the output in file A. Then you make some refactoring change to the program, run it again, output to file B. Then compare A and B with diff. It'll show you the differences. And filter to word count. Well, diff produces no output at all if the files match. So if you get 0, there was no change and your refactoring was successful. Otherwise, you can look at A and B, you can look at what the output was before you made the change and after you made the change, and get a clue at least what you did wrong. And as long as you're getting 0, you hit up arrow enter after every little code tweak that you make. Tweak, flip over, up arrow enter, rinse, repeat. Very efficient. With slightly more typing, instead of piping to word count directly, you redirect to a diff file that you named. Here I call it ab.diff. Oh, I guess I should mention that particular syntax might not work on Windows. In curly braces, I've got a comma b. Like curly a comma b curly dot text is a Unix way of saying a.text space b.text is a shortcut. I didn't spot that. Okay. It's a great shortcut though. Works in Mac too. So we're going into ab.diff and we're running word count on that. Now, if you don't get a 0, then you can view that ab.diff file without rerunning the diff. A little more typing, but gives you quicker access to what changed. This combo is especially good when you are mixing refactoring with bug fixes or new features. So when you make a change that you do expect to change the output, you don't just want to see a line count of the changes. You need to look to see, did it change the way you expected it to change? You need to look at the difference file. And if it didn't change, then you know something was wrong. And that, with the exact same keystrokes, still gives you the 0 information that you're expecting when you're in a refactoring stage. So this combo lets you keep the same commands in your up arrow history instead of switching to a bunch of different commands. And the capstone is that when you have verified that a diff is the droid you're looking for, like, you've made the change, you're expecting it to have done this thing different, you look, it did that thing different, then you just move B On top of A goes away. Now you've got a new set point of what the output's supposed to look like. And so those last three things, you just up arrow no more than 3 times, cycle through. It works a dream. All right, next real world filter combo. Sort unique C, sort NR. If I ever start sleep typing, this is what I will type in my sleep. Does anybody else use this regularly? Great, great, glad to hear it. I'm glad to hear that there are like 6 people, and I'm glad to hear that there are a lot that it's not yet. Because that's validation, right? Now it's not just me talking. So you have many lines of data coming in. You pipe it to sort, not because you care about getting it in a particular order, but just to make sure that any lines that are identical are together. They need to be like touching. That gets piped to unique, which compresses duplicate lines into one line. The -C puts a count to the left of the line. So if a line occurred 5 times, you get 5 and then the copy of that line. And that gets piped to sort again with a flag to sort numerically on the first field, which was the counts that we just put in reverse order. Yeah. Okay. Here's what it looks like when you use it. Perl just dropped an exciting new release. OCD is not among my ailments, but we all know a foolish consistency, da-da-da-da. Uniformity has a shiny appeal to my ADD. I downloaded the source, I unpacked it, changed directory to its location. I want to use grep to search for the shebang lines. Anything in the source code with those 2 characters, technically it's an octathorpe, the hash sign or pound sign, not in Britain, that and exclamation mark, octathorpe, exclamation mark, shebang. Anything that has that is probably an instruction to run Perl from a particular location on disk. And it's very important because when you're building Perl, some of the time you need Perl that's already installed on your system to be running things so it can build the new Perl. And other times it needs to be running the new Perl because you're testing the new Perl that isn't installed yet to make sure it works. So I'm expecting to see some differences, but not a lot, because that's just 2 cases I spoke of. The capital R flag to grep will make me recursively search down through all the directory, subdirectory, starting at the current one. That's what the dot is. And the H flag stops grep from also prepending which file the line came from, which that's normally what grep does if you give it more than one file. That would get in the way of the sorting we're going to do to get all the like ones together. So I'm going to pipe all that. I should just be getting the lines that have the shebang in it. I'm going to pipe all that through sort unique C, sort NR. And feed that to head because only 14 lines will fit on the next slide. There's quite a lot of variety there. More than I expected. Maybe somebody should look into that. Or maybe I'm just being neurotic about it. Well, that one in particular seems bizarre. Run it using the Perl that's in the pro directory. What's the pro directory? Well, I think somebody ought to look. Some of this is explained because some of it is coming from documentation on how to write programs. That's why some of it's indented. And I don't know if capital T, lowercase w flag is different from lowercase w, capital T flag. Anyway, that's the kind of output, that's the kind of lightning quick data analysis you can get on some data. Oh, no. Okay, different example of the same technique. I've got a file that all the lines are unique because I know because it's coming from a database system, the first field is a unique field. But all the other ones, all the other fields need to be unique as a record. And they're not. I need to find that. It'll give me a clue as to why they're not unique. So CSV cut, if I used a lowercase c, then I'd be saying what columns I want. But with an uppercase C, I'm saying what columns I don't want. So get rid of the first column, and then run that to sort unique C, sort in R, and pop it up in my editor. And I have clustered at the top all the ones that are greater than 1, and some of them are greater than 2, which should be completely impossible, but there it was. These command lines sometimes grow up to become scripts. They're the starting point of data exploration or data munging and exploratory programming. And the next step is you make a real program based on the command line that you refined 25 times. And now it's too long, it needs to be a full program. Well, when I do that,